We are with a new question, and the question is based on the dipoles. So let's start with the question. Question goes like, two charges plus minus 10 microcoulomb. These are two charges having two different polarity. So how dipole is formed? A dipole is formed by the charges having same magnitude, but the polarity will be different. One will be plus q, while the other will be minus q. Here our value of plus q is plus 10 microcoulomb, and similarly our minus q's value is minus 10 microcoulomb. Okay, are placed 5 mm apart. So distance between these two charges is 5 mm. 5 mm. Okay. Determine the electric field at a point P on the axis of dipole. On the axis of dipole implies on the same axis, either here or on this side. We'll read further question to understand which side they are saying us. 15 centimeter away from its center O on the side of positive charge. So this is our positive charge. Center of dipole is this. This is O. From this center, we have to find electric field at this point P. Electric field over here is questionable. We don't know. And how much is this distance? This is 15 centimeter. 15 centimeter. The dipole's length is 5 mm. Okay, dipole's length is 5 mm. Whereas the distance of the point P where we need to find the electric field from the center of dipole is 15 centimeter. And what they are saying, it is at this side of positive charge. So this is positive charge, and from here this is in the side of positive charge. Now, and at point Q, other question, this is the B part of question. Okay, B part of question. The question in the book is given as a whole, but whenever we read a question, we need to understand what they want as A and what they want as B. So this is B part. What they are saying, at point Q, capital Q, 15 centimeter away from the O on the line passing through O and normal to the axis of dipole. What will be normal to the axis of dipole? A equatorial plane. Okay, this is normal. This is O. This is plus Q. This is minus Q. And our point Q is over here. And how far it is from O? Again, it is 15 centimeter. What is the distance given here? It is 5 mm. Okay. So they are asking in the question, they are asking us electric field at point P, which is on the same axis. I'll write here on point P on same axis, and point Q, which is on the equatorial plane. Equatorial plane. Okay, so these are the questions they have asked. We have to find electric field at these 2 points, and what is the distance, what is the location of these 2 points is explained in the question. So let's move to the solution part. Q1 and Q2 are, magnitude of Q1 and Q2 is 10 microcoulomb, which are placed 5 mm apart. Here we are dealing with millimeter. Okay, it is a very extremely small dipole, millimeter. Whereas the distance of P and Q is 15 centimeter from O. P is 15 centimeter, cm, quite a long distance compared to the distance of dipole. From O, Q is also 15 centimeter. Okay. Now at point P, we are dealing with A at point P, which is 15 centimeter away on the axis of dipole from its center O on the side of positive charge. We have condition. First condition, it is 15 centimeter away. Second, on axis of dipole. Third, from center. This value is from center 15 centimeter, and the last one is in the side of positive charge, inside of positive charge. Okay, these are the conditions we have to take in account while we are making a diagrammatic representation of the question. Like if we are not able to represent our question in diagrammatic way, we will not be able to get an idea what is happening and how we need to find out the electric field. So see, this is minus 10, this is plus 10, and this whole system is making a dipole. This whole system is making a dipole, and they are 5 mm apart. From there, this is the distance till P, which is 15 centimeter apart, and at the side of positive this one charge. See, this one is positive charge at the side of positive charge. So we got an idea that we need to find electric field here. That there will be like electric field due to positive charge, due to negative charge. Negative charge is around 15 plus 0.5 centimeter away, whereas our positive charge is 15 minus 0.5. 5 mm equals to 0.5 centimeter. From negative, what is the distance? 0.5 plus 15. And from positive, what is the distance? 0.5, like 1, this will be like 15 minus 0.5. So see, 0.5 is a very small value when compared with 15 centimeter. When compared with 15 centimeter, 0.5 is very small. So this is negligible in nature, and we can actually remove it, or we can simply make it very small and hence negligible in nature. Hence negligible. Okay. So now we will deal with the question. Our Q is 10 into 10 to the power minus 6 coulomb. 1 micro implies 10 to the power minus 6. Okay. So that's how we have converted our microcoulomb to 10 to the power minus 6 coulomb, and electric field is given by 2p divided by 4 pi epsilon naught into r square. So here we will get the value of E equals to 2 into 2 from here, 2a into q. Dipole P is given as 2aq. See over here. So 2a into q. Now what is the value of 2a? 2a implies the whole value between plus charge and minus charge, that is a 5 mm. Okay. That 5 mm will be converted into centimeters and then to meters, and it will come around 0.5 into 10 to the power minus 2 meter, or simply you can write it as 5 into 10 to the power minus 3 meter. Okay. So now substituting all these values, whatever values we have got, we will try to find out electric field at P. So we'll just see how we are doing that. Okay, moving to the. So first of all, we will see few formulas which we will be needing to solve this question. Okay, so just see over here. We will go with dipoles when our point on the dipole is present on axis. Like this is our dipole minus q plus q, and this is our point P, and this one is r, distance from the center, and this one is our 2a. Okay, and here P vector represents dipole. Usually dipole is given by P equals to 2a into q. 2a is the distance between the dipole into the charge of dipole. Okay, distance of dipole into charge. Now this is called as axial dipole, or the point on the axis of dipole. So I'll just write axis and I'll give you the formulas needed here. The formulas which are needed when the point P is influenced by negative charge, the dipole, the electric field we will get is 1 by 4 pi epsilon naught into QP by R plus A the whole square. Okay, and electric field due to the influence of positive charge will be given 1 by 4 pi epsilon naught, here no negative charge, into Q into P divided by R minus A the whole square. See, the distance from this to this point, the distance from this to this point is R plus A, not 2A. Like from center, if we see, this is center, this is A, and whole it is making 2A. So no need to worry about 2A, it should be just A. And when we will see from this point, okay, this extra highlighted point to the point P, the distance is R minus A. That is what we have taken here, the distance. Okay, so hope the how we have taken the distance is clear. So this is for plus, this is for minus. Now E total for both is given by E minus Q plus E due to plus Q. We will solve it in the class of electric dipole. I have already shown you the derivation of this. You can refer that class for knowing the derivation. And E minus Q plus E plus Q, the values we will get will be like this one. I'll show it up. Like K, Q, here the value of K is 1 by 4 pi epsilon naught. Just for simplification I am writing KQ, and into P, these are the in the numerator, divided by R square minus A square the whole square into 4AR. So after solving it up, we will get 4Q into A divided by 4 pi epsilon naught into R cube into P vector. Now from where does this R cube came? We are taking this A is very much smaller than R. Like A is very much smaller than R, so A square will also be extremely smaller than R square. Hence A square equals to negligible. That's how we are getting this formula. This one is E equivalent at axis. Now we will see the case for the equatorial plane. Equatorial, how does that happen? This is our charge plus Q. This is our another charge minus Q, and here is our point Q where we have to find the electric field, where E to be found. Okay, so this and this is our R, this is our 2A, this is our center. Okay, So due to both this charge and this charge, the electric field will be same for both plus Q and minus Q. E will be same at point Q, and hence E for plus Q is given as KQ by R square plus A square into our P. Okay. Similarly, for E minus Q, it is given to be KQP divided by R square plus A square. That is how we are getting this R square plus A square is the distance from this point to this, from Q, this is plus Q charge to point Q. See, we are using Pythagoras theorem here. This is R, this is A, this is O. So according to Pythagoras theorem, R square plus A square whole under root will give us hypotenuse of a right angle triangle. Hypotenuse of a right angled triangle. Okay. So the equivalent E will be, it will come around K into 2Q AP divided by, that's so in negative because both these one of the values is negative, and here we will get as denominator R square plus A square the whole 3 by 2, that will be E equivalent. Okay, so these are the formulas you should know before solving this problem. So we will see here, it is 2 into 2 into 0.5, that is the length of dipole, length of dipole. This is the magnitude of charge, and this is the value of constant K, So after solving it, we will get the value of our dipole to be 2.67 into 10 to the power 5 Newton per Coulomb. So that is the electric field at point P due to plus minus 10 microcoulomb of charge. Similarly, now we will go to the solution of problem number 2. Here our point Q is at equatorial plane 15 centimeter away from the O. So what will be this distance? It will be 15 square plus 0.5 square under the root. So again here the concept of that 0.5 centimeter being smaller than 15 centimeter will be negligible once the power comes into role. Negligible once the square or cube, these are like powers, okay, powers comes into role play. Okay, because 0.5 square is 0.25, which is a smaller value than 0.5. If we will cube it, it will be 0.125, which is further smaller value. So if we are giving power to a small value, it will become smaller than the previous one. So once we are using the powers, it is of no use. It can be like turned as a negligible one. Okay. So going forward for the equation, we got this equation Kp by R cube. In the equatorial plane, electric field is given by this formula. Here K is our constant and 2aq is the dipole's expanded formula, and r cube is the distance which we have taken in account by just removing the value of r in from the value of a from the formula. So see here the how we have taken the numerals. This is k and this is dipoles A, and this is our charge q, and this is the distance between the charges and the point q, charges and point q. After solving it, we'll get 1.33 into 10 to the power 5 Newton per coulomb, that is the electric field at q. So one thing in this discussion we can say is that the electric field at axial is more than the electric field at equatorial plane for the same set of dipoles. So the strength is reducing as we are moving far away from the charges. So other way to solve this same problem is you can find electric field due to minus q and electric field due to plus q, first for the point P, and then electric field for minus q and electric field for plus q for point q, and these individual fields can be summed up to get a equivalent E. That is also one of the way to do, and other way is that in our NCERT textbook they have given us a summed up expression, which I have told you in the previous slide. That summed up expression we can use, we can directly substitute the given numeral values into it and find the strength or magnitude of electric field at the respective points or the points asked in the question. So hope this question was understandable to you all, as this is the easiest sum and very simple, just taking the formula and applying the numeral values, that's it. So follow it up and try to solve it by yourself, and you can apply this second method also. Individual electric field due to individual charges, you can find and make a sum up to check whether you are getting the same values or not. So that's all for today's class. Have a good day.